The question is, state parallelogram law of vectors, derive an expression for the magnitude and direction of the resultant vector. Statement is, if two vectors starting from a point are represented in magnitude and direction by the adjacent sides of a parallelogram, then the resultant is represented in magnitude and direction by the diagonal passing through the same point. That means, for example, if we take two vectors starting from a point, so this can be taken as first vector and this is second vector. So they're starting from the same point over here. Let the first vector is given by OP, which is equal to A bar. Second vector is given by OQ, which is equal to B bar. So they too represent the adjacent sides of a parallelogram. So to construct a parallelogram, we have to draw two more parallel lines. One vector parallel to OP bar starting from Q and other vector starting from P, which is parallel to B bar. So now we can see that a parallelogram is constructed. Then the resultant is represented in magnitude and direction by the diagonal passing through the same point. So from the same point, if we draw a diagonal, so this diagonal represents the resultant both in magnitude and in direction. So first of all, to derive the resultant, which is given by R here, so here R bar is equal to A bar plus B bar. So in the diagram, OP is a vector given by A bar, OQ is a vector given by B bar, and QS is parallel to OP, PS is parallel to B bar. And let, for example, theta is the angle between the two vectors A bar and B bar. Now, to derive the resultant, first of all, we need to get a right angle triangle. To construct a right angle triangle, so first let us extend the line OP and we will draw a line perpendicular from point S so that this line intersects the extended line OP at point N. The vector PS is also equal to B bar. So here B bar is a vector which makes an angle theta with horizontal. Therefore, the value of Pn becomes B cos theta. Means I can say that the component of the vector B bar along the direction Pn is B cos theta. And the component of the B bar along Sn is B sin theta. So the value of Sn is B sin theta. So now by using the right angle triangle SON, we should find out the magnitude of the resultant. So now I can see from the triangle SON, by using Pythagoras theorem, we can write OS square is equal to ON square plus SN square. Again, OS square is equal to, the value of ON can be taken as OP plus PN. OP plus PN whole square plus SN square. So the value of OP is A and the value of Pn is B cos theta. The value of OS is R square is equal to A plus B cos theta whole square plus, and the value of Sn is B sin theta plus B sin theta whole square. Next step, now R square is equal to A square plus B square cos square theta plus 2AB cos theta plus b square sine square theta. Next step, now this implies r square is equal to a square plus, so here we can see b square cos square theta, and here we have b square sine square theta. We can take b square as common, b square into cos square theta plus sine square theta plus 2ab cos theta. So now r square is equal to a square plus b square. We know that cos square theta plus sin square theta is equal to 1 into 1 plus 2ab cos theta. So r we can write now r square is equal to a square plus b square plus 2ab cos theta. Then resultant magnitude is given by r is equal to root over a square plus b square plus 2ab cos theta. This is the formula for the magnitude of resultant. So now we shall find a direction of the resultant. So now in the diagram, let alpha is the angle made by the resultant vector r bar with the vector p bar, with the vector op bar. So now again from the triangle, SON, we can use tan alpha is equal to opposite side, that is SN, by adjacent side, that is ON. So now tan alpha is equal to SN value is, we know that already, b sin theta, and ON value is a plus b cos theta. So now the value of alpha is given by alpha is equal to tan inverse of b sin theta by a plus b cos theta.